So this gives you an illustration of how does a spaceship go from Earth to Mars. So you got blue Earth there and red Mars. And I mean, the actual distance traveled on the Ark is close to like 1,000 times further than the Moon. So you can't just go straight to Mars. You have to create this elliptical orbit with Earth at one point and Mars at the other side, at the far end of the ellipse, and then time the where you are in that ellipse to intersect with Mars. And this is the orbital transfer, how you do orbital transfer from Earth to Mars. And if you look on your Starlink Wi-Fi router, you'll see this image, because the Starlink Wi-Fi is Starlink Internet is what's being used to pay for humanity getting to Mars. So I'd just like to thank everyone out there who's bought Starlink, because you're helping secure the future of civilization and helping make life multiplanetary and helping make humanity a space-faring civilization. Thank you. So this is a tentative game plan here, where we're hoping to achieve, where we increase the cadence of flights to Mars dramatically with every launch window. So every roughly 2 years, we are dramatically increasing the number of ships that go to Mars, and ultimately try to get to 1,000 or 2,000 ships, per Mars rendezvous. So I mean, as a rough order of magnitude, this is just guesses, obviously, but we need to get about 1 million tons, is my guess, to the surface of Mars to make a civilization on Mars self-sustaining, and get to that critical point where if the resupply ships from Earth stop coming for any reason, Mars still succeeds. Mars can still grow. And so you can't be missing anything. You can't be missing even like the equivalent of vitamin C or anything. You've got to have everything you need for Mars to grow. That's essential. So my guess is that's about 1 million tons, but it might be 10 million tons. I hope it's not 100 million tons. That'd be a lot. But we want to try to get to that point and secure the future of civilization as quickly as possible. So we're looking at different locations. The lead candidate right now is the Arcadia region. So and Mars has a lot of real estate, but when you combine all of the factors and say, okay, we can't be too close to the poles. We need to be near ice to get water, and can't be too mountainous for the rockets. Then it narrows down to a smaller region. So Arcadia is it's one of my daughter's name is Arcadia, actually, and is one of the options. So we got the first Starships on Mars, gather critical data. So the first flights there we'll send with the Optimus robot, so we can go out there and explore and kind of prepare the way for humans. And that'll be a very cool image if we're able to achieve it by launching end of next year. It would actually technically arrive in 2027, but that would be an epic picture to see Optimus walking around on the surface of Mars. And then with launching 2 years later, we'd be sending humans. Assuming the first missions are successful and they land successfully, we'd send humans on the next mission, and we'd really start building the infrastructure for Mars. So anyway, maybe just to be safe, we might just do two landing episodes with Optimus and do the third one with humans. We'll see. So that classic picture of the workers on the Empire State. And then for communications on Mars, we'll be using a version of Starlink to provide internet on Mars. Yeah, so the speed of light, even at moving at the speed of light, your best case scenario is, I guess, running around 3.5 minutes to Mars, and then worst case is 22 minutes or more because Mars is on the other side of the sun from Earth. So anyway, it's quite challenging to do high bandwidth communications with Mars, but Starlink will achieve that. Yeah, and then we'll have the first humans lay the groundwork for permanent presence on the surface. And yeah, the goal, like I said, will be to make Mars self-sustaining as quickly as possible. So it's just a sort of rough idea of what things will be like with the first city on Mars. My guess is we'll probably put the launch pads a little further away, or the landing pads, just in case. But I mean, for Mars, we're going to need a lot of solar power. We'll be, since you can't really walk around on the surface of Mars, at least as yet, until Mars is terraformed to be like Earth. You need to walk around with a Mars suit and be, initially in kind of like glass domes. But it would work, and eventually we can make Mars into an Earth-like planet. And we want to get to the point where we're transferring over 1 million tons at every Mars transfer window. And then that's like a serious civilization. A megaton per transfer window. So, yeah, I have a lot of spaceports. I mean, because of the fact that you can't fly there continuously and you have to transfer in these windows, you'd have a gathering of 1,000 ships, or 2,000 ships, or more than that. So we have this kind of like Battlestar Galactica feel, where all these ships are in orbit, waiting to depart, and then they'd all depart. I look at, I think, an amazing image of all these ships departing at once. And then you're going to need, obviously, a lot of launch pads, a lot of landing pads on Mars. Or you'll need to move the ships off the landing pad pretty fast. So if you've got, I don't know, a few thousand ships inbound, probably need at least a few hundred pads, landing pads. And anyway, we'll solve that problem later. So, yeah, anyway, this is like an incredible thing to have, like this amazing city on Mars, the first city on another planet, and a new world. And it's also an opportunity to, I think, for the Martians to rethink how they want civilization to be. So you can maybe rethink, like, what kind of form of government do you want? What new rules do you want to have? There's a lot of freedom and opportunity in Mars to do a recompile on civilization, which will be